Hi, today we're looking at section 3.3, solving inequalities by multiplying or dividing. In the last lesson, we looked at solving inequalities by using addition or subtraction. So again, please take notes, take something out to write on and write with. And you can always pause the video when you're taking notes. And after each of the examples, you'll have your chance to do the check it out problems. Today we have two learning targets. The first one, I can solve one-step inequalities by using multiplication, and I can solve one-step inequalities using division. Let's look at the properties of an inequality. Using multiplication and division by positive numbers is what we're going to start with. So when we're multiplying both sides by the same positive number, our inequality should remain true, and the same with division. So looking at multiplication, if we have 7 is less than 12, the inequality is true. We multiply both sides of the inequality by a positive 3. We get 21 is less than 36, and that inequality remains true. Division, we have 15 is less than 35. Again, that inequality is true. Dividing both sides by 5, we get 3 is less than 7, and that inequality also is true. Algebraically, if a is less than b and c is greater than 0, so c is a positive number, then a times c is less than b times c. And again, the same holds true for division. If a is greater than b and c is greater than 0, then a divided by c is still less than b divided by c. And these same properties by a positive number, multiplication or division by a positive number, hold true for the other three inequalities: greater than or equal to, or less than or equal to. So let's run through some examples. So our first example, 7 times x is greater than negative 42. So let's solve this one and then graph the solution. To solve this inequality, we want to get x by itself, so we divide both sides of the inequality by 7, leaving us with x on the left-hand side and negative 6 on the right. And the inequality just carries down, so x is greater than negative 6. So graphing this inequality, we have an open circle at negative 6 because negative 6 is not part of our solution, and we shade everything to the right. Again, notice our inequality symbol matches the same direction that we're shading to. Now we need to check our answers and see if our solution is correct. So checking our solution, we first check our endpoint at negative 6. Plugging that in for x, 7 times negative 6 does equal negative 42, so our endpoint is correct. Now let's pick a number. In this case, 0 would be part of our solution. So substitute 0 for x, 7 times 0 is 0, and 0 is greater than negative 42. So our inequality sign is facing the correct direction. Now let's look at our second example. 2.4 is less than or equal to m over 3. To solve this inequality, we multiply both sides by 3. 3 times 2.4 is 7.2. And we're left with m on the right-hand side. So m is greater than or equal to 7.2. So we have a closed circle at 7.2 because m can equal 7.2, and we shade again it's greater than, everything to the right. And yes, we need to check our solution. So let's check our endpoint first. 2.4 equals 7.2 divided by 3, and it does. 2.4 equals 2.4. So our endpoint is correct. Now let's pick a solution that, in this case, is not part of it. 0 would not be shaded. So 2.4, is it less than or equal to 0 divided by 3? It is not. So 2.4 is not less than or equal to 0. So 0 is not part of our solution, and it's not shaded. So nice job with the shading. And our last example, 3 over 4 times r is less than 12. Solving this inequality, r right now is being multiplied by 3/4, so we have to multiply it by the reciprocal, which would be 4/3 on both sides, giving us r on the left-hand side and 16 on the right. Our inequality carries down, so r is less than 16. So graphing this, we're going to have an open circle at 16 because 16 is our endpoint, but it's not part of our solution. And it's going to be less than, so it shades everything to the right. And again, we need to check our solutions. So plugging 16 in for our endpoint, 3/4 times 16 is 12, and 12 does equal 12, so our endpoint is correct. And again, let's pick a number. We can pick 0. In this case, 0 would be shaded, so it should be a solution. Let's check. Is 0 less than 12? It is, so we've shaded the right direction. It is now your turn to do these 3 check it out problems. So now let's look at inequalities used with multiplication by a negative number. So we multiply both sides by the same negative number or divide both sides by the same negative number. We need to reverse the inequality symbol. So in this example, 8 is greater than 4. We multiply both sides by negative 2. 8 times negative 2 is negative 16. 4 times negative 2 is negative 8. So negative 16 is less than negative 8, and our inequality signs change directions. For division, 12 is greater than 4. We divide both sides by negative 4. Left-hand side is negative 3. The right-hand side is negative 1. And negative 3 is less than negative 1. And again, note that the inequality symbols were reversed. And this is what it looks like algebraically for multiplication and division. Make sure you copy these properties into your notes. And also note that it holds true for the less than, greater than or equal to, and less than or equal to inequality symbols. So let's look at some examples of multiplying and dividing by a negative number. Our first example, negative 12x is greater than 84. So just like in an equation, when we get the x variable by itself, so we divide both sides by negative 12, leaving us with x on the left-hand side and negative 7 on the right-hand side. Since we divided by a negative number, we need to reverse our inequality symbol. So it's going to be x is going to be less than negative 7. Open circle at negative 7, and we shade everything to the left. And we can check this, again, with our endpoint. Negative 7 times negative 12 is a positive 84, so our endpoint is correct. And 0 is going to be over here, will not be shaded, so let's plug 0 in. Is 0 greater than 84? No, so 0 is not part of the solution, so we shaded the correct direction. Now let's look at negative 8 is less than or equal to x divided by negative 3. So to solve this inequality, we need to multiply both sides by negative 3 to get the variable by itself. So on the left-hand side, negative 3 times negative 8 is 24, positive 24. And on the right-hand side, we get our variable by itself. Again, keeping in mind we want the variable on the left-hand side. We get x is less than or equal to 24. Graphing this, we have a closed circle at 24, and we shade everything to the left. So let's check and see. When x is 24, 24 divided by negative 3 does equal negative 8. And again, this time 0 would be shaded, should be part of our solution. So let's see. Is negative 8 less than or equal to 0 divided by negative 3? Yes, negative 8 is less than or equal to 0. So we've shaded correctly. Before you do your check it outs, let's look at some common errors. Or let's look at some for these problems, see if there are any common errors in here, and make sure you avoid them. The first one we're going to look at is negative 4n is greater than 28. So we have to divide both sides by negative 4, leaving us with the n on the left and negative 7 on the right, and our inequalities flipped. So with this one, this is correct. Now let's take a look at x divided by negative 8 is less than or equal to negative 2. To solve this, we have to multiply both sides by negative 8, leaving us with x on the left and a negative 16 on the right. And again, our inequality signs change direction because we divided by a negative number. So this inequality was solved correctly also. There are no errors in these first two. Now let's take a look at this one. T divided by negative 5 is greater than or equal to 4. Again, multiply both sides by negative 5. We're starting out good. Multiplying by a negative number, we reverse our inequality. But notice we lost the equal to. So this one does have an error. When you're rewriting your inequality symbol, make sure you don't drop the equal to part of the inequality. And for our last one, we have 3p is less than negative 4.5. So again, divide both sides by positive 3, leaving us with p on the left and negative 1.5 on the right. But uh-oh, the inequality sign flipped, but we divided by a positive number. We do not reverse the inequality sign at that point. Now it's your turn to do these two check it out problems. Our last example, Jill has a $20 gift card to an art supply store where 4-ounce tubes of paint are $4.30 each after tax. What are the possible numbers of tubes that Jill can buy? Keep in mind, Jill cannot buy partial tubes. So with any story problem, let's define our variable. Let p equal the number of paint tubes Jill can buy. So our inequality becomes $4.30 times p is less than or equal to 20. Her gift card's only up to $20, cannot exceed that. Solving it, we divide both sides by 4.3, leaving us with p is less than or equal to 4.65. Again, she can't buy partial tubes, so she can purchase 0, 1, 2, 3, or 4 paint tubes. And here's your check it out problem. So in summary, when you're solving inequalities, it's just like solving equations. If possible, try to keep your variables positive. When dividing or multiplying by a negative number, your inequality sign will change direction. When writing your solution, write the variable on the left-hand side, and always check your solution. Plug in the endpoint. It should be a true equation. And check your inequality symbol. Pick a value if 0 is possible. Put 0 in and see if your inequality is true or false, if it should be a part of the solution or not. Thank you. Bye-bye.